Okay, so for this problem, we're going to use the quotient rule and the chain rule, which I like to call the outside-inside rule. The first thing that I want to do is rewrite f of x. And I think that you guys are doing well with the calculus. It's the algebra that's kind of messing you up. So the first thing that I notice is that in the denominator of this fraction, there's a greatest common factor of 2 that I can pull out. You don't have to do it this way. It's just, to me, it's going to help me later on. The other thing that you definitely will help you is to remember that when you have a negative exponent outside of a fraction, to make the exponent positive, you flip the inside so everything on the inside flips, and that will make the outside exponent positive. Okay, so that's an exponent rule from algebra. Here's another exponent rule that we're going to use. A power on the outside will go to each individual. I'm going to put parentheses around this 5x plus 1 inside. So we'll have, what this turns into is 2 to the 4th, which is 16, times x minus 2 to the 4th over the 5x plus 1 to the 4th. So this is now my f of x. So if you've watched the other video, you know that I like to go ahead and find the derivatives of the top and bottom, or the individual factors, first. It just makes it easier for me when I'm plugging. So I'm going to do that right here. I'm going to say that I've got y equals 16 times x minus 2 to the 4th, which is my high in my little quotient rule over there. So the derivative of that is going to be 16 times the 4 I bring to the front, and then I reduce the exponent by 1. So 16 times 4 will give me 64. X minus 2 to the 3rd. So that's the derivative for high. Now I want to find the derivative for low. So low is the 5x plus 1 to the 4th, and for this one we're going to have to use the chain or the outside inside rule, which says we're going to take the derivative of the outside. So the 4 is going to come out front. We leave the inside the same. Reduce the exponent by 1, so it becomes a 3. And then you take the derivative of the inside. So the derivative of 5x plus 1 is 5. And when I multiply the 4 times 5, we're going to get 20 times 5x plus 1 to the third. Okay, so now I'm going to use all this information for the quotient rule. And the way I remember the quotient rule is low d high minus high d low all over low low. So I've got all that information, and now I can start actually working the problem. So purple's my favorite color, so let's just use it. And this is just here as a reference. We're going to use this as the original f of x, and so we want to find f prime of x. And we're going to be following this quotient rule. So the low is 5x plus 1 to the fourth times the derivative of the high. And so I can look over, and in blue, the derivative of the high is 64 times x minus 2 to the third minus high, so 16 times x minus 2 to the fourth d low. So in the green, we'll have the 20 times the 5x plus 1 to the third. That whole amount is over low times low. So 5x plus 1 to the fourth times 5x plus 1 to the fourth. Okay, now I'm going to change here, and because there's a whole bunch of algebra involved, I'm going to write that I'm working on the top only right here. I'll put it all together, but for right now, I want to work on the top only. So I'm going to take this first set, and it will give me 64 times 5x plus 1 to the fourth times x minus 2 to the third. Now the only reason I did that is because traditionally we put constants to the front, so I just kind of reordered that. Then subtracting, I need to multiply the 16 times the 20, and that will give me 320 times, and I want them in the same order. It doesn't have to be, but the 5x plus 1 to the third times x minus 2 to the 4th. Now remember, I'm doing top only right now because I'm just kind of manipulating it with calculus. So I'm looking at this and I want to pull out the greatest common factor. And the greatest common factor of 64 and 320, believe it or not, is 64. If I look at the 5x plus 1, it is in both terms, so I can pull it out. And you pull out the smallest exponent, so the third. And if I look at the x minus 2, it's also in both terms, with the smallest exponent being 3. So that's my greatest common factor. And so now I'm going to simplify. So the 64 and 64 divide out. With the 5x plus 1, I've got a 4, but I've got, when I pulled out 3, that leaves just the 5x plus 1. Because I pulled out 3 of the 4. And for the x minus 2 to the third, it also cancels out in that first part because they're the same. I'm going to subtract. Now, 320 divided by the 64 will leave a 5. If I look at the 5x plus 1 to the third, I've already pulled that out. If I look at the x minus 2 to the fourth, I've pulled out 3 of them, so there's 1 left. All right, so still top only. And you don't have to write all this, but I'll tell you what, I do, because if I don't write it, I lose it. So the 5x plus 1 just is 5x plus 1. But I'm going to distribute that negative 5. So I'll have a negative 5x plus a 10. Well, when I combine like terms in there, 5x plus 5x cancels, and I actually get 11. So because we're running out of space and I want to get to the answer, I'm going to go ahead and just kind of, since I've said it, I'm going to erase all of it. And we end up with the 1 plus 10, which is 11. So if you need to, just rewind and watch, but that's where the 11 comes from. So now I've got the 11 times 64. So the 11 times 64 is 704 times the 5x plus 1 to the third over the x minus 2 to the third. Okay, so all of that was top only. So now let's go back and put it all together. So our derivative we'll have the 704 times the 5x plus 1 to the third times the x minus 2 to the third all over, and we can look up here and you can see what I'm highlighting. That's my low times low. And your old exponent rules tell you when you have the same base, the 5x plus 1, multiply means add the exponents. So 4 plus 4 is 8. We've done a lot and we're almost done. We keep the 704, and for the 5x plus 1, I've got a 5x plus 1, I've got 3 on the top, I've got 8 on the bottom. So that's going to mean that I'm subtracting those exponents, and since I have more on the bottom, that's where the 5 goes, the exponent that's left. And then I have the x minus 2 to the third. And that is my final answer. And you can see that it does match what Pearson said. I hope that's helpful.